Hello, good afternoon. We are going to work on 11.3. It's our last lesson for chapter 11, comparing two samples. Today, we're going to talk about inferencing about two means, independent samples. So it's quantitative data, but they're two separate independent samples. And I just want you to write down at the top where we're going to go in statcrunch. We're going to use statcrunch today for that. So you're going to go to stat, and then T-stats, and then you're going to choose two samples. And then one of the examples we're going to do today will have summary data, and one we're going to have a data set, and you can find that data set in statcrunch. I'm going to share it with everyone. So this is kind of the outline of how this hypothesis test will go. We have our four pieces of requirements. Only if requested for the central limit theorem, a random sample size, n independent samples, so they have to be independent from each other. We have to verify their independence of the population, so each individual sample, and then we also have to prove normality using our either each sample size has to be greater than or equal to 30, or we have to have normal probability plots with no outliers. This is what our hypotheses will look like. Notice that you're just comparing one sample to the other. You're not comparing to a value like we did in chapter 10. We have a left-tailed, a two-tailed, or a right-tailed. And notice that as before, whatever hypothesis test we're doing will coordinate with the picture on all three of these. Step 2, you have to let me know what level of significance we are using. You need to define your test statistic, which is, remember, it's your fancy z-score. Just use technology, don't fill it in, just tell me T0 equals, I'm using statcrunch. Draw your picture that's appropriate. Step 5 is comparing your p-value to the alpha. Let me know if you reject or do not reject H0, and then make sure that you state your conclusion. And you can find this in your gold sheets as well. So the first example we're going to do today says we want to test whether there is a difference in the body temperature of men and women. We collect a random sample of 65 women and 65 men and take their temperatures. The summary statistics are shown below. So it says verify that the conditions needed to conduct a hypothesis test of the differences in the mean temperatures between females and males are met. So our first requirement is that we have random sample, and they did tell us that they took random samples of each. 2 random samples. The second requirement is that the men and women are independent of each other. So the 2 samples are independent of one another. The third one is we are checking to make sure that 65 on each of these, 65 is less than 5% of all men in, we'll say, in the US, and yes, it is. So 65 is less than or equal than 5% of all men. Yes, I would say that. And then 65 is less than or equal to 5% of all females. That's safe to say on that one. And then the fourth one is that our sample sizes are big enough. And so sample size of the females is 65, and that's greater than or equal to 30. And then the sample size of the males is 65, and that's also greater than or equal to 30. So those have all been met. Part B says, conduct this hypothesis test using the p-value method at a level of 0.05 in your calculator, which we're going to use statcrunch. So the first one is we need to find our hypothesis statement. And it just wants to know if there's a difference between the two body temperatures. So our hypothesis statement is going to be the two-tailed one right here. So mean 1 is equal to mean 2, where mean 1 is not equal to mean 2. Our alpha is 0.05. They gave us that right here. We're going to go to statcrunch to get our t statistic momentarily. And then our picture that we're going to draw is two-tailed because our hypothesis statement was two-tailed. And we'll tie that in with our step 5, our p-value that will come out of statcrunch, and we're going to compare that to our alpha. And then once we've compared our p-value to our alpha, we can state our conclusion. So let's go ahead and go to statcrunch and enter in our summary statistics. So in statcrunch, we're going to go to stat and t-stats, to sample with summary, and we're going to enter in the mean and standard deviation and sample size of each. And then we're clicking on hypothesis test, and it's a not equal to. Note the default was recently changed to off. So we are not going to pool our variances. So just leave that. Do not click on the pool variances. And we're going to hit compute. And there we go. Is our test statistic is 2.28. So we're just over 2 standard deviations above the mean. Difference between them. So there's a positive difference. So it looks like we did females subtracting males. So it looks like females tend to be a little bit warmer in their body temperature, which I'm surprised by because I'm always cold. And then there's our p-value, 0.024. So let's go back to our paper here, and we can fill in our test statistic of 2.284. And our p-value is 0.024. And remember, when it's two-tailed, we just kind of draw 2 arrows. It's spread out between there. And it's definitely less than 0.05, so we do reject H0. So there is sufficient evidence to support the claim that males and females differ in their body temperatures. Which is interesting. Okay. So if we flip the page, we're going to look at confidence intervals for this data here. So we're on page 253. This confidence interval is also on your gold sheet. So it's right here on your gold sheet. And then only do the requirements if we request them. Otherwise, we're just looking at this confidence interval. And also, we're going to statcrunch. It's going to be the same that we did before, stat and t-stats, 2 samples. Then you're just going to choose an interval instead of the hypothesis test. Okay. So we have data. So you can find this data in statcrunch momentarily. It says researchers suspect that drinking tea might enhance the production of interferon gamma, a molecule that helps the immune system fight bacteria, viruses, and tumors. A study involved 21 healthy people who did not normally drink tea or coffee. 11 of the participants were randomly assigned to drink 5 or 6 cups of tea a day, while 10 were asked to drink the same amount of coffee. After 2 weeks, blood samples were exposed to an antigen and production of interferon gamma was measured. The results are shown in the table. So notice that the sample sizes are different. So if you're wondering if we missed a data point here, we did not. There were 11 tea drinkers and 10 coffee drinkers. It says verify that the conditions needed to conduct a hypothesis test so the differences in the mean temperatures between females and males are met. And this is not the body temperatures. This was the differences in the tea and coffee. So differences in tea and coffee biting antigens. So yes, that was a typo that will get fixed. Oh, here. So our first one is, yes, we have random samples. 2 is this 2 groups are independent of each other. The third one is our sample size 1, 11, less than 5% of, and we want to talk about all, we're just talking about all people, right? So yes, it's less than 5% of all people. And N2, which is 10, is definitely less than 5% of all people. And then the fourth thing is our sample sizes are small, so we have to use the normal probability plot. And these boundaries here show that it is normal and there's no outliers. So both are linear with no outliers. Okay. So if you want to go ahead and go to the data in statcrunch, because B on page 254 is asking us to construct a 95% confidence interval for the mean difference in the means for the 2 groups. So just give the result and do not show your work. So let's go to statcrunch. And you can look, it says, I titled it Course Pack 11.3 Coffee and Tea. And there we are, the tea and the coffee. And they were collecting their antigen. So they were collecting their production of interferon gamma, the molecule. So we're going to stat and t-stats, 2 samples with data this time. And so our first values are going to be in the T column, and then our second sample is the coffee column. We're doing a confidence interval of 95% and hit compute. And there is our lower and upper limit. And I'm going to just fill this in here. It is a negative 0.1974 up to 34.43, which is a really big confidence interval. It's pretty wide. And let's just go back to our paper so we can do the rest together there. It says compute the point estimate for the interval. So to do that, we can add our upper and our lower, negative 0.1974 plus 34.43 divided by 2. And our point estimate comes out to be approximately 17.12 or 17.116, I think is around there. It says compute the margin of error for the interval. And so I'm going to use the upper minus the point estimate, upper minus the point estimate, which is essentially mean, x bar 1 minus x bar 2. And so that's going to be 34.43 17.43 minus 17.12, and that comes out to be 17.31. Interpret the confidence interval in the context of the situation. So we are 95% confident that the true difference between tea and coffee drinkers in making interferon gamma level between a negative 0.1974 and 34.43. And F says, does this interval suggest there is a significant difference in the interferon gamma production between the tea and coffee drinkers? Explain. No. Because 0 is within the interval. So if it says, does the interval suggest there is a difference? You can say yes or no. If it says, does this support or conflict, then you need to tell me if it agrees or doesn't agree specifically. And that wraps up chapter 11. We will be working on the review later on.